Yeah, genes change as you age.
That's crazy. I found a Pac-Man in 95 in my house.
My dad used to have blonde hair. Now he has gray hair.
My dad used to have red hair.
Someone did create a bill. These houses have drywall. And you know, drywall makes sense. If you buy new ones, like I bought the cheapest mask at the time, and those were it. And I'm like, now these masks are going to be a problem.
Oh yeah.
Yeah, what?
And I just found a 3-pack, like in a drawer. I was like, wait, I have one. Like,
Now, it would be a great business venture to buy lots of masks and just start selling
I don't know
them.
why people do that. Go on eBay and they're charging you so much.
People are buying them because they're
Yeah,
scared.
he has like cancer.
But also, like, they don't really help that much.
You do that?
Taking advantage of fearful
Yeah, because there's no plans.
The counter argument to that is always the same.
I'm sorry. Yeah.
Ice Gap. It's not, it's just, this is free market. The problem is, like,
I really hope I don't
free market.
What determines whether that's price gouging?
put on sunscreen.
If
I really don't know.
so can your screen do a full rotation?
Yeah.
Can you spin it back?
35.
It has little numbers.
I blame the F-35.
I just wanted to
making
get
it have to move.
freaking spin it.
Okay, let's go ahead and get started. Who can name these two aircraft?
The
F-35 and what? Or
Boeing version of it.
32. Yeah. So basically the Boeing version, Lockheed Martin version. So we're gonna watch a quick video, basically looking at the design teams going through this. And most of you probably haven't seen this. It's an old Nova from about 10 years ago. And what they were doing is they allowed film crews to come in during the process of the engineering teams developing the aircraft. So they followed them for about 2 years, kind of the office style, coming in and videoing them making their design choices, running into the problems with the design of their aircraft and figuring out how to solve those problems. So this is a 2-hour-long program. We're only watching a short segment of it. So the choppy editing that you see in here is not PBS, that's on me, right? So I'm not a very good editor. But you'll see both pictures of the Boeing team and pictures of the Lockheed team, or segments as they go through the process. One of the things I want you to keep in mind is that the design requirements are the same. Both teams are handed the same RFP, saying here's what the aircraft has to do. Both teams have the same set of engineering and physics to work with. Okay? What they do have are different company cultures and different company expertise that they specialize in. And so they end up with two very different aircraft designs. Okay? All right. Yep, I'm sure sound here is working.
Boeing took a step back and said, what makes airplanes expensive? How can we leave it out? And they got a very, very simple design.
Boeing's expertise in wings has kind of taken a different tack. Our engineers have chosen to build this wing as one piece from tip to tip. We have always studied the idea of building a one-piece wing and attaching the fuselage to the wing. And so this time we had an opportunity to really try it.
Boeing has taken to heart the JSF concept, meeting the needs of the Air Force, Navy, and Marines through a versatile common design. And it even accommodates the biggest JSF challenge, landing like a Harrier. While it gets a bad rap for safety, the Harrier is no doubt the most adaptable fighter ever built. Matching its capabilities will drive many of the design decisions of the competition. When fully loaded with fuel and bombs, a Harrier takes off in as little as 500 feet, a third of that needed by most fighters. That short takeoff distance makes many roads into potential runways. After an attack, it returns, a lighter fighter. ready to execute its trademark Buck Rogers move. A Harrier hovers using rotating nozzles that direct engine exhaust downward. This mode of flight, called direct lift, demands an enormous amount of power. And it's dangerous. Before computer control, balancing a Harrier on its own engine thrust was like trying to sit on a geyser. Even today, its accident rate is 4 times that of a Navy Hornet. But through their flexibility, Harriers have proven their value. In fact, in the Gulf War, Harriers flew more missions than any other kind of fighter. For the British, the Harrier remains essential. British aircraft carriers are smaller than their American counterparts. The Harrier's short takeoff ability overcomes the problem and creates a portable fighter force.
The Harrier has allowed the UK basically to be where it couldn't be. The Falklands was a classic example. I mean, without the Harrier, we could not have defended the Falklands. We couldn't have got any aircraft down there. But the ability to put a reasonably competent combat aircraft onto a deck and get it down there and then fight was just the difference between success and failure.
But the Harrier can't fly supersonic. A serious limitation in a modern fighter.
In terms of its turn performance, its range and endurance, its maximum speed, whichever metric you want to look at, it fares unfavourably with any modern aeroplane.
We also have brothers in arms with the US Navy, so from them.
The British search for a replacement Harrier brings them to the JSF table. They become full partners. It's the first time a foreign government has been included in an American fighter development program. The addition of the British only heightens what many consider the central technical challenge of the JSF competition, landing the fighter vertically. Alternatives to the Harrier's direct lift system have been studied by both contractors, but Boeing has come to a surprising conclusion.
Over the years, all contractors have looked at all of these various lift methods, and the least impact of the design always and has been direct lift.
The Boeing lift system is basically the modern version of the Harrier. Taking the engine thrust and putting it through a pair of nozzles that direct it downwards. The advantage that Boeing has is that you basically strap on the lift module around the engine. So the changes are pretty minimal.
The fewer the changes between the Marine fighter and the other versions, the better the bottom line. Boeing has made an ally of affordability.
So I believe when we're all finished doing the flight test, we'll have proven that direct lift offers the absolute greatest affordability because of the greatest commonality.
While direct lift is affordable, other parts of the plane must pay a price. For balance during hover, the engine must be in the middle. That leads to a gaping inlet to feed it air. To some, Boeing has designed a plane only its mother could love.
It's a strange looking aeroplane. It's short, it's squat, the engine's in the front, not the back. It has this huge air inlet in front that reminds me of a hippopotamus.
It's a fighter competition, not a beauty pageant. But there is an adage in aerospace that if it looks right, it flies right. And appearance may be a deciding factor.
So a couple comments on this. First off, hippos kill more people in Africa than any other animal. I don't know why someone hasn't named an aircraft hippopotamus. But if you think about where you're at right now in terms of making design decisions, you'll notice all the metrics that they've already listed off. So they have to be able to design something that replicates the Harrier's capabilities, but has much better performance in all of those metrics. You know, speed, range, endurance, payload capability, all the things that we talked about. And so even though this is very fighter-centric, you can broaden this discussion to pretty much any type of aircraft design. You know, what we're going to see eventually coming down the pike once these systems become more affordable and proven, is the capability to use these in commercial applications. You know, think about your urban air mobility solution, or your Uber Air taxi, where you can have some type of vertical takeoff and landing capability to move people around town using a fixed wing system rather than using a rotary wing system.
Appearance aside, Boeing's proposal is a cunning entry for the JSF competition. Throwing over fighter tradition, the company delivers a radical but simple design that promises to be cheap to build. Boeing's ready to give its aerospace opponent a flight to the finish.
When I daydream, I see it hovering, I see it taking off from airfields, I see it operating around the ship, and sometimes I even see it shooting down the Lockheed airplane.
Does anyone recognize that name? Yeah, so he was the CEO of Boeing up until about 2 months ago. So he was fired because of the 737 MAX issue. But don't feel bad for him, he left with about $62 million. He has an island somewhere now.
By the time Lockheed earns its place in the final JSF competition, Chief Engineer Rick Rezebek and his team have already spent 5 years designing their fighter. Now they must build a pair of test planes in just 2. If Lockheed wins, their work will live on for decades. If it loses,
the stakes are horrendous on this. This program will end up running from today out through the year 2050. Long after my retirement, the performance of this team and the decision making that goes on during these next 2 years are very key.
the mystique of the Skunk Works remains unrivaled in aviation. But back at Boeing, it's hardly been smooth sailing. The latest results from computer simulations are pointing to an alarming conclusion. Boeing's entire delta wing design may be fundamentally flawed. The Navy has refined its requirements and wants a more maneuverable plane that can carry more weapons. Boeing's delta wing design is now seriously overweight.
So this is something we call requirement creep. So it happens all the time when your customer comes and says, hey, why don't you just go ahead and do this as well? Just add on another 1,000 pounds. Or hey, can you carry more payload? Or why can't you fly another 500 nautical miles? Not realizing how big of an impact it's going to have on the aircraft.
Months into building the test planes, Boeing's lead engineers conclude that the only way to lose the pounds is to abandon the Delta and come up with a new wing and tail design.
We are at a point in the process here where we need to make a decision on the tail. I think we're really struggling with which way to go.
An engineering team led by Dennis Mullenberg must come up with a new tail design that will work on a reconfigured fighter. The conventional choice is called a four-poster, for its 4 control surfaces. The tail design for all modern U.S. fighters, including Lockheed's Raptor and its proposed JSF fighter. But there is an experimental alternative, a novel 2-post tail with just 2 angled control surfaces. The Pelican tail is named after its inventor, an engineer inherited from McDonnell Douglas, Ralph Pelican. He argues its merits.
Sure, I understand you're all nervous about this new concept. I think it can be done.
Proponents of the Pelican tail argue that the design is less visible to enemy radar. In other words, it has a smaller stealth signature. For Boeing, this is an important plus, since Lockheed is the originator and acknowledged master of stealth technology.
We can't afford to have any question at all over our signature and whether we're making a signature.
I don't think that we really know enough about the Pelican tail. You know, we think we can make it work, but how much effort is ahead of us to make it work?
Those supporting the traditional 4-post tail argue it's a known quantity. The word on the street is that the JSF program managers favor it for the same reason.
There's a slight benefit from a strategy standpoint that we can negate a perceived Lockheed advantage by going to a 4-poster. On the other hand, we end up looking like the follower in, with two teams that have the same design.
I vote for the Pelican tail. I think we've got to bite the bullet and go there.
I guess maybe I'm still a little more conservative than Fred, and I would stick with the 4-poster and try and get the signature to work with the airplane with the 4-poster.
But your probability of getting hit.
The room is deeply divided.
I'm talking about if you have a failure.
In the end, Mullenberg must break the tie.
Now, I've been a 4-poster fan up until about an hour ago. All right? I think we can beat the pants off Lockheed when it comes to working weight, handling qualities, aerodynamics. Whether it's real or not, they're perceived to have a signature advantage. So we need to do something to our configuration that will give us a signature advantage. I think the Pelican tail does that. All right?
Feeling pressure to make a bold choice, Mullenberg chooses the Pelican tail.
About some things, so let's go figure out how to make it work.
But just days later, after Frank Statkus and senior management review the choices, Boeing changes its mind. Concerned about weight and performance, it commits to the more conservative 4-post tail.
Is signature versus weight. The 4-poster is a little safer way to go. So I was a little torn from a personal standpoint, but when we stood back and looked at the data, I think we made the right decision.
Boeing radically changes the wing and tail design, which gives the proposed fighter a fresh new look. The new plane is projected to be 1,500 pounds lighter and more agile. But it's too late to incorporate the design changes into Boeing's 2 test planes, now 8 months into assembly. Instead, the company will submit the new configuration with its final proposal. By testing the new design in simulations and wind tunnels, and flight testing the old design, Boeing believes it can prove the soundness of its approach.
All right. So, what do you notice most about that design discussion that they had? And not even talking about the details in terms of how they were making their decisions.
Discussion.
Competition.
Yeah. So how are design decisions typically made?
Not good at a vote to me.
Who knows what the answer to this is already? Has anyone watched the video online for trade studies? If you have, right, you'll know the answer to this question. So this is an acronym used in industry. VOGSAT. Bunch of guys and gals sitting around talking. Which you saw how that discussion evolved in that conference room. Basically, just people arguing and saying, "Oh, I think it should be the 4-poster. Oh, I think it should be the Pelican tail." And whoever kind of yells the loudest at the end of the day kind of wins out until management overrules everything and says, "No, never mind. Go back to this decision process." And one of the things that we try to get away from is this process right now, because at the end of the day, you want to be able to go to your customer, whoever that customer may be, and if they ask the question, why did you decide on this particular design? Rather than having a qualitative answer, such as, oh, it's more conservative, we think we can make it work, you need to have something based in engineering that provides some fundamental capabilities for you to actually draw strong conclusions from, and that's where the trade study process comes in. So what I would like you to do, if you haven't had an opportunity to watch it yet, is make sure you watch that video lecture, because it does go through this process in detail, how we use trade studies to come up with a much more rigorous approach to making those design decisions, rather than just saying, hey, I like this, you like that, flip a coin and see what we get. Okay. Yes?
So wasn't part of the problem there, because since they were considering a tail design that had been tried, tested, they had engineering numbers for, but then the Pelican design was one that hadn't been used yet.
Sure.
That's what they were debating.
Yeah, pretty much. Which way do you want to go? Do you want to go with something that's conservative and tried true, or do you want to take a risk and try something that is, you know, maybe a little more of a compelling argument from lots of different reasons. You know, personally, you know, I'm a fan of the Pelican tail just because it's new and novel. That doesn't necessarily mean that would be the best approach to go, because you do have to demonstrate that the thing is going to work at the end of the day.
Is there, I don't know of one off the top of my head, is there a plane out there now that's?
Actually, I've never seen one. Yeah, not familiar. So, but any other comments about, you know, that approach, the video that they took? Keeping in mind that both teams have the same set of engineering knowledge. You know, one is more sophisticated in manufacturing, one is more sophisticated in stealth, but no one has a magic bag of tricks that they can reach into to come up with a design. What you didn't see, obviously on the Lockheed side, is their decision to go with the lift fan solution, which gives them a much more familiar fighter aircraft profile, you know, versus what you saw on the Boeing design. I mean, the F-35 looks much more like an F-22, and obviously Boeing's aircraft did. But that was also a risk that they took to demonstrate that they could actually get it to work, because it hadn't been done before. So you can make that same argument, say, well, this has never been demonstrated in an aircraft before, so, you know, that's a big risk that essentially you have to take onto the design team when you do that. Any other questions or comments about that?
Who won? Hey, Lockheed.
Yeah, who won? Everyone should know that in here, right? Lockheed won.
Lockheed always wins. All the smart people we have to be 50. Maybe if the other one wasn't so ugly.
All right. So yeah, this is the F-35 now, right? You can't see these. They have one of these at, I think, the Pensacola Naval Air Station. I'm trying to remember what the other one might be at the Wright-Patterson Air Force Museum. So. The only other thing that I don't like about, you know, that particular process that you saw is the real kind of lack of diversity that you see in the conference room. So there was not a single female engineer in that. So yeah, luckily they've changed a lot in the past 20 years. Keep in mind that this is still pretty old. So, all right. Okay. Now, so what I think I'm going to do in this is we'll do a fairly, what concerns me, it came up in a question, someone asked, well, what's a trade study? And that's why I want you to watch the video so you know what a trade study is. And it goes through the process, because you need that as part of your design project right now, is to understand the trade study process. So make sure you watch that video, and we'll set up a simple quiz with some questions. For example, what is BOGSAT? Now you know what BOGSAT is. And the rest of that is actually going through the trade study process. This is another example I always like to pull out, right? Which ones are these? Yeah, so this is the YF-22 and the YF-23 here. Right? So this was, you know, for obviously for the advanced tactical fighter competition, and the F-22 won this. You can argue that this was a much more evenly matched competition between the two aircraft. You know, if you kind of hear the anecdotal stories from the test pilots that ran through this, you know, this was a turn and burn, this was a screaming demon. So, you know,